Welcome to the final revision for grade 11 math exam. Before we start with the questions, we first have to say that there are many formulas and many concepts that you have to be familiar with in order to be able to solve all of these questions. That being said, we can start with the first question, which is if the matrix A is, he gave you this matrix, then element, so element they mean by a number, A 3x1 or 3 cross 1. So we first have to know that this 3, the first number, represents the number of rows, and the second number represents the number of columns. All right, so if we go to the third row, so this is the first row, second row, third row, okay, and we draw a circle. And then we go to the first column, which is this one, and we draw a circle. We can see the intersection is happening at number 1. So the answer here is 1, okay? We can do the same thing here. So this time it's 1 cross 3. So we go to the first row and to the third column, and we can see that the intersection happens in element or number 7. Okay, now we can go to the second question, which is he gives you matrix A and its order, which is 2 cross 3, and then he tells you that it was multiplied with matrix B but without its order, and it will equal AB, the new matrix, with its order, which is 2 cross 2. Now the question is, what is the order of B here? What is the order of B? Well, in order to solve this question, we first have to know that when we multiply two matrices, the first matrice's number of columns should match the second matrice's number of rows. So what does this mean? It means that the first number must be a 3, okay, in this, because 3, this and this should equal to each other, okay? Cross. Now what is the second number? Now we can cancel out all the things that are similar. So 3 and 3 are similar, 2 and 2 are similar, so the last thing here we have is 2. So it means that the order of B is 3 cross 2. We can make sure that we have the right order by multiplying the actual two matrices. So we say 2 cross 3, and then we said that B was multiplied, which is 3 cross 2. So we see that these two are conformable, so we can delete them, and AB will be, the order of AB will be the first and last, so it'll be 2 cross 2. If we go to the question, it is 2 cross 2, so we have the right answer. We'll do the second question, same exact thing. So order of matrix A or matrix A is 4 cross 3. Order of B is unknown, which will equal the new matrix C, which is AB 4 cross 2. So we said this number here, the closer one to the B, should equal the same thing. So 3 cross, and then this and this we cancel out. 4 and 4 we cancel out. The last thing we have is 2. So the order of B is 3 cross 2. Okay, so this is the answer for the second question, and for the first question this is the answer. Okay, now let's go to this question. So it says here that this matrix C should equal this matrix C, which means that the first element here should equal the first element in the second matrix C, and the second element in the first matrix C should equal the second element in the second matrix C. So if you write the two equations, which is 2a minus 1, it should equal, according to this one, it should equal 5. And then if you write the second formula, or the second equation, which is negative 3b, should equal the second number, which is negative 3. Okay, now let's solve. Here the question is, what is a minus b? So let's get the value of a, which is, if we transform negative 1 to the other side, we'll get 2a equals 6, and then divide by 2, so a equals 3. So we got the first number, which is 3, minus, as we have here. Then the value of b is, if we divide by negative 3, this and this will go, and the negative will go, which means that b will equal 1. So here b equals 1. So 3 minus 1 is equal to 2. We do the same thing here, which is 2a minus 1 equals 7. So here 2a minus 1 equals 7. And here negative 3b equals negative 3. So again here we'll transform 1 to the other side, which means that 2a will equal 8. Divide by 2, and a is equal to 4. So here we have 4 minus again. Then the same number, which is we divide by negative 3, this and this will go, negative negative will go, 3 divided by 3 is equal to 1, which means that 4 minus the value of b should equal 1, just in the like the first question, which is here. So 4 minus 1 is equal to, pardon me, 4 minus 1 is equal to 3. Okay, so let's go to this question. So if he tells you that this is the matrix of X, then what is X transpose? Basically, what transpose means is that we take a row and we make it into a column. So to show this off easily, we can take this row and we can convert it into a column. See? And we can see here that our new row should be -1 and 6. And if we do the same thing again, we'll take the second row and then we copied it. So our second column should be equal to 4 and -5. This is a more visual representation. So we can just imagine it if we put this as a row and if we put the second row as the column. Pardon me, I meant to say column. So to make sure that we have the right answer, the first element and last element should still equal each other in the second transpose version. So here we have -1 and -1, and here -5, -5, which means that it is correct. Okay, same thing here. We convert this row into a column, so it means that we have -1 and 4. Then again here we'll have 3, then -5. Again, first element is same, last element is same, which means that we have the right answer. Now, in this question, they basically tell you to what is the value of 2a plus 3b. 2a is basically the matrix of a multiplied twice, and the matrix of b multiplied by 3. Okay, so let's take this matrix and multiply it by 2, just like in the question asked. So we'll say, what is the matrix here? So it will be 4 times 2 will be 8, 3 times 2 will be 6, -2 times 2 will be -4, and finally 2 times 1 will be 2. Okay, then we'll have the second, so we'll put plus here, just like in the question. The second matrix will be multiplied by 3 everything. So -3, see here, -3 times 3, 2 times 3, 5 times 3, and 7 times 3, like here. Okay, so that will be -9, 6, 15, and 21. Okay, now how do we add up matrices? First of all, we need to know that in order to add up matrices, the orders must be identical. They should be the same. So if A is 2 cross 2, B must be also 2 cross 2. That also applies in subtraction too. Okay, so we take the first element with the first element and we add them. So we'll say that 8 plus -9 is -1, 6 plus 6 will be 12, -4 plus 15 will be 11, and finally 2 plus 21 will be 23. So this is our answer. And then, so this is 12, to make it more clear. Same thing here, we'll multiply matrix A by 4. So it will be 4 times 4 will be 16, 4 times 3 is 12, 4 times -2 is -8, and 4 times 1 is 4. We have here plus, so plus. Then B is everything times 5. So -3 times 5 is -15, 10, 25, and 35. Okay, so same thing, first element with the first element. So 16 plus -15 is equal to 1. Then we have 12 plus, here, let's see, wait, I didn't write it too. Okay, so times, so yeah, this is 10. I thought it was 16. So yeah, 12 plus 10 will be 22. -8 plus 25 will be, I believe, 17. And finally 4 plus 35 will be 39. So this is our answer. Okay, now let's solve this system. So let's just clear things up here. Let's solve this system by using multiplicative inverse, which means that we'll first of all convert this equation into matrix form. How do we do this? We take, first of all, we make a matrix, and then we take the first number and second number, which is the coefficients of the variables. So say 3 and 5. Then we'll take, again, we go to the second row because we finished this equation. We go to the second equation and we write the coefficients, so 2 and 3. Okay, so we write x and y, you'll see now y, and it will equal b. What is b? So b are what the equations are equal to. So it is equal to 27 and 17. Okay, so now here let's for example, let's label this matrix as A, label this whole matrix as X, and label this matrix as B. If we want the value of X, we'll need to convert or like put A into the other side. We'll have to divide this matrix by both sides, right? But we can't divide in matrices. What do? We write the inverse of them. So if you multiply here by A inverse and here by A inverse, A and A inverse will cancel each other and we'll be left out with X. So X is equal, which is the one we want, to B times A inverse. So what is A inverse? A inverse is basically equal to A adjoint over A determinant. Now, what is each of these? Okay, so A adjoint, we can solve via using our actual, here, let's use our, here, okay. So let us use the matrices that we'll be working with. So basically, let's first of all get the determinant of A. To get the determinant of A, we'll have to multiply these two together. Let's name them as A, and then subtract them from these two together after we multiply them together. So let's label this as B. So it'll be A minus B, and A is equal to 3 times 3, which is equal to 9. So here we'll have 9 minus 2 times 10, or sorry, 2 times 5 is 10, which will equal to negative 1. So A inverse here, or sorry, A determinant will equal to negative 1. Now, what is A adjoint? So to get the adjoint of this matrix, or this matrix, we'll take these two together and replace them with each other, their positions, okay? But since they are equal to each other, then both of them, nothing will be changed. But for example, if we had a matrix like 2, 4, 7, 6, and we said let's get the adjoint of this, it will become 6, then 2, and then blah blah blah, etc. Okay, so then what we'll do is we will take the opposite sign of these two numbers, okay, which means, or two elements, which means that this will be negative and this will be negative. In case this was already negative, it will become positive because it's the opposite sign. So this is our new matrix, and we can divide it by A determinant, which was negative 1. Okay, so now we can just divide each element by negative 1, and then it will be just the opposite signs, same matrix but opposite signs. So it will become negative 3, then 5, 2, and negative 3 again. Okay, now we got A inverse. This is what A inverse is equal to, but this is not the answer. The answer is A inverse times B. What is B? We said that B is 27 over 17. How do we multiply? Well, in order to multiply two matrices, first of all, as we said, their order, the number of rows should equal, the number of columns in the first matrix should equal the number of rows in the second matrix, okay? So we'll take the first row and multiply it by the first column. So it'll be like this, negative 3 times 27, so first element with first element, plus second element with second element, so it'll be 5 times 17. And then after we finish from this row, we can go to the second row in the first matrix, and we'll say 2 times 27 plus negative 3 times 17. Negative 3 times 17. Okay, we can use now our calculator, so let's use our calculator. Okay? So the first row will equal to 4. And the second row will equal to 3. We can see that the order of this matrix is 2x1. And if we go to the first, to our matrices to make sure that we have the right answer, we have the answer here. So this matrix has an order of 2x2, and this matrix has an order of 2x1. And then if we take, basically, we cancel out these two together. So we will have 2x1 as our new matrix order. And we can see that this equals this, which means that we have the right answer. We can do the same exact steps with this question, but to cut some time, I won't do it. But basically, we just do the exact same steps. Okay? Now here, to be able to solve most of these questions, we'll have to be familiar with the identities, trig identities. So here, for example, 1 plus, there's a mistake. There should be a plus sign here. So what is 1 plus tan square x? This should equal to sec square x right away. How do I know this? Well, you must be familiar with the trig functions. What is sine 2x? Sine 2x, let's see. So we have them here. If we use the first, if we use the original sine a minus b or sine a plus b, and then replace b with a, we'll get this new formula, which is sine 2a. And sine 2a is basically equal to, if we go back here, sine 2a or sine 2x is equal to 2 sine x cosine x. This is what sine 2x is equal to. With cosine x, we can do the same thing. So if you go back here, we use the formula for cosine a plus b. So we cannot use the minus version. But if we use the a plus b version, we'll replace b with a, and again we'll get the last formula, which is here. The answer will be here, cosine here. Let me make sure I have the right formula. Yeah, so it is squared. So cosine squared x minus sine square x. Now I have to remember that we have two versions of this formula, because we can convert either cosine into sine or sine into cosine. So we have the cosine version and the sine version, or in terms of sine version. Okay, so if you want to convert this into cosine, in terms of cosine, the formula will become 2 cosine x, square x, minus 1. And if we, this is the in terms of cosine. And if we want to convert it into in terms of sine x, it'll become 1 minus 2 sine square x. So these are the three formulas for cosine 2x, which is already derived from cosine a plus b. Okay, so what is 1 minus sine squared x? We just said it here. What is this equal to? Well, we have to first know the identity, which is sine square x plus cosine square x should equal 1. So if you see here, what does this equal to? If you convert, if we put sine to the other side, we'll get this formula. Cosine square x is equal to 1 minus sine square x. So we can see that these two values are the same, which means that this is equal to cosine square x. And if we go, is that it? Yeah, we have this one. This is the same exact thing, but just the opposite. Instead of putting sine into the other side, we put cosine into the other side, which will give us the same thing. So this will equal to sine square x, using the identity as we said, sine square x plus cosine square x will equal to 1. Okay, if you go down here, I believe there should be a plus sign here. So if you see here, we have cosine square x plus tan square x times cosine square x. So what does this mean? If we write cosine square x, the same thing, but we write plus, we write the value of tan square x as sine square x over cosine square x times cosine square x times cosine square x. We can cancel out cosine and cosine here, so we'll essentially have cosine square x plus sine square x, which, as we just said, if we go back here, sine square x plus cosine square x is equal to 1. So this is the same thing. This will equal to 1. Here again, cosine square x times sec square x minus cosine square x. Well, cosine or sec square x is basically the opposite of cosine, so we can cancel out these two and we can write them as 1 minus cosine square x. And we just said here, if we go up a little bit, 1 minus cosine square x is equal to sine square x. So this will equal to sine square x. Okay, let's go here. So 2 cosine square x plus 1 is equal to 2 plus, okay, so first of all, we have to know that cosine of 2x, in terms of cosine, we said that it is equal to 2 cosine squared x minus 1. Okay, so if we see here, they are kind of similar, but the only difference is that we have here minus 1 and here we have plus 1. So what we essentially did was we added 2, okay, to this equation, because we added 2 because then it became 0 and then 1. So it is the same exact thing. We'll just write cosine of 2x. Okay, so it is the same thing, but that we just added 2 to both of the sides. 2 cosine square x minus 1 is equal to basically cosine of 2x without adding anything. So this is the original formula. As you can see here, it is minus 1. And then it derived from here, because we added 2 here, we added 2, then we have to add 2 on the other side too, because whatever we do on one side, we should do on the other side. Then if we go here, so sec x times sine x times cotangent x. So let's first of all write them in terms of their reciprocals. So 1 over cosine x times sine x times cotangent x, which is the opposite of tan, that being cosine x over sine x. Okay, so sine x and sine x will go, cosine x and cosine x will go, leaving us only with 1. Okay, last slide. In order to do these questions, we will have to memorize or understand the entirety of the unit circle. That is very vital. We also have to know that the first term here refers to cosine and the second term here refers to sine. We also have to know that if you want to get the value of a degree in the first quadrant, well, it is equal to what? It is equal to the degree itself. But if you want to get it in the second quadrant, then it will equal to the degree. So we'll have to write 180 minus this degree. Let me write it like this, okay? But in case we want to get it in the third quadrant, so third quadrant, we can use the formula 180 plus the degree. And finally, in the fourth quadrant, we write 360 minus this degree. So it doesn't matter what this degree is. If we start solving these questions, you'll understand in each case we can use these, okay? But because we don't want to use the unit circle all the time, because in the test you won't be provided with one, so you'll have to actually understand these formulas. So what is sine x of 1/2? But here, that's the interval. And the interval is basically telling you that he wants the values of sine x, which is equal to 1/2, in between the interval of 0 to 2 pi, which 2 pi is basically equal to 360. So here's telling you what is the value of, let's just start solving so it makes more sense. So we want the value of x, right? So we'll have to write x, which is equal to, we put sine to the other side, which means we make it inverse. So sine inverse of 1 over 2, okay? So what is the sine inverse of 1 over 2 in the entirety of the unit circle? So if we go down here, we see that we want the sine. So the second, let's, if we name this x and this y, we want have to be in the y section. So we see that y is present in 30 degrees. And if we go here, we look for any more angles, we see that 150 also has it. But be careful. Here we do have 1/2 and 210, but this is negative 1/2. So we don't want negative, we want only the positives. And yeah, same thing with here, 330, okay? So what if we just know 30? How do we get the other angle? As we said, so if we want to in the second quadrant, we also have to understand ASTC, all student take calculus. Um, if we said that we want positive half, so we'll understand that for the sine, it'll be positive in the first quadrant and the second quadrant only, okay? So third and fourth, we don't want to use these. We don't want to use the formula in the third and fourth, which means that we only care about these two. So the first angle, the first quadrant is 30 degrees, as we said. But to get it in the second quadrant, if we don't memorize the unit circle, we can say 180 minus the degree, which we have right now as 30, which will give us 150. And surprisingly enough, that is our answer. If we go here, 150, as you can see here, is also 1/2. So what does this mean? It means that the sine inverse of 1 over 2 in the interval of 0 to 2 pi is 30 degrees and 150 degrees. Okay, so now we go to the second question. Almost same idea, just instead of sine we have cosine. So if we want the value of x, we put cosine to the other side, which will give us x equals to cosine inverse of 1 over 2. Okay, same thing. What is the cosine inverse of 1 over 2? We know that in the first quadrant it is equal to 60. If we go here, we see this time it's in the x values, so we go to 60 and we see here 1/2. So if we go here, where is cosine positive? We see that it is positive in the first quadrant because here is all. In the second, it's sine only, so no, we don't want that. In the third, it's tan only, so no, we don't want that. But it is in the fourth. So let's use the formula for the fourth quadrant. So we said that 360, that's constant, minus the degrees. This time our degree is 60. So our second value for cosine, cosine 1 over 2 should equal to 300 degrees. And if we go down here to make sure, we can see that it is correct. Here, this is cosine and this is sine, and cosine is equal to 1 over half positive and 300 degrees angle. So it means that our two angles, the answer to this question is 60 degrees and 300 degrees. Okay, so what is tan 5 pi over 12? There should be here 1. There's another mistake. Find the exact value. So in order to do this question, we'll mainly use our calculator for this, but to some extent we'll have to show our work. And in order to solve this question, we'll have to solve it this way. So let's first of all convert 5 pi into degrees, which is basically time multiplying 5 by 180 over 12, which will give us 75. So here essentially they're asking us what is tan 75. And since this isn't an angle that we usually use, so if we go here, 75, we cannot find it in the unit circle. It's not one of these values. So how do we find it? We can basically use our four angles, which are 30, 45, 60, and finally 90. These three angles will give us any combination that we want. So we realize that 75 is a composition of 45 and 30. If we add them together, which means that tan, we can use x plus or a plus b, we'll use this formula. Tan a plus b, which is here. Let's go down. Tan a plus b. Here it is. Oops. So, what is tan a plus b? Tan a plus b is equal to this formula, okay? So, here we said that what we want to find is tan 75, which is equal to 30, or let's just write 45 plus 30, okay? Now, let's write the formula. It is tan a, so tan a, which is 45, so we want tan 45, plus tan b, which is plus tan b, which is tan 30, over 1 minus, we take the reciprocal, so in the numerator we take the exact same sign as the one in the formula or the equation, but in the second, or in the denominator, we take the opposite. 1 minus tan a, which we just said is tan 45. This time we multiply it by tan 30. Now, let's go to the unit circle, because I don't really remember it so far. So, what is tan? Tan, as we said, is basically a composition of sine over cosine, okay? So if we go to 30, this is the angle of 30. Tan is basically, we'll take sine, this is sine, and this is cosine. So we'll take sine, which is 1 over 2, and then divided by cosine, which is the under root of 3 over 2. So this is equal to tan 30, okay? Plus, we said tan 45. So if you go to 45, we'll do the same thing. We'll take the sine here and cosine here. So we'll take under root of 2 divided by 2, then divided by, again, under root of 2 divided by 2. And if we use the experiment, if we take the tan of 45, it should equal to 1, okay? But for the sake of using this question, let's just take these two together. Okay. Hopefully I have it. Okay, so this is tan 30 and this is tan 45, okay? Divided by 1 minus, as we said, this is tan 30, so let's just duplicate it again, make it smaller so it fits, and then tan 45. So if we put this entire thing into the calculator, it should give us the value of tan 75. Okay, so now we're done with this question. We can move on to the next question. So let's just let's clear up some space. Okay, so solve sine x sine 2x plus cosine 2x times cosine x, which is equal to 1 over 2. We see that this looks like the cosine formula, which is cosine a plus b is equal to, here, let's write it so it can make more sense. If we go here, cosine a plus b is equal to cosine a and cosine b minus sine a and sine b. Okay, but here they have it in the opposite. We have sine first. So sine a should be, let's write it as 2. And then since we have it here as positive, we'll take the inverse for cosine. So write minus, and sine b should be x, so 1. And this will give us, or it should be actually 2x minus 1x, which will give us cosine x, because 2x minus 1x is equal to x. And this will equal to 1 over 2. And then, again, cosine 1 over 2, we said is equal to 60. And, 60 degrees. Here, because they didn't ask us for certain intervals, I believe we should provide for all the angles. So we say 300 degrees too. Then again, in the second question and final question here, it says cosine square x plus cosine x is equal to sine square x, and they want this in the intervals of the entire unit circle from 0 to 2 pi. So our first step should be converting sine square x into cosine. And how do we write this? This equals to 1 minus cosine square x. If you ask us how, we'll use the cosine square x plus sine square x is equal to 1. Convert cosine, or sorry, convert sine to the other side, and we'll get this formula. So this should equal cosine square x plus cosine x, and then if we go to the other, we input, sorry, if we convert cosine, negative cosine square x to the other side, it'll give us 2 cosine square x plus cosine x, which is equal to 1. Again, convert 1 to the other side, we'll get the final formula, which is 2 cosine square x plus cosine x minus 1, which is equal to 0. If we just don't mind the cosine, this equation looks like it is 2x squared plus x minus 1, which equals to 0. And we can factor it into 2x minus 1 times x plus 1, which will equal to 0. So if we multiply the first by first and the first by second and second by first, second by second, we'll get this equation again. Okay, so let's just write this exact formula, but in terms of cosine. So we write here 2 cosine square x minus 1 times cosine square, sorry, not with square, just 2 cosine x minus 1 times cosine x, here, cosine x plus 1. Now we'll have to get the roots for each of these. So to get this should equal to 0. One of them should equal to 0, obviously, if they will equal to 0. So this will equal to, if we just put, so okay, let's just write it so it makes more sense. 2 cosine x minus 1 is equal to 0. So we put negative 1 to the other side and then divide by 2. So it'll give us cosine x is equal to 1 over 2. And again, this is equal to the, okay, let's just have this by the side for now. Then we'll go to the second formula or second equation, and this will give us, if we say cosine x plus 1 is equal to 0, put plus 1 to the other side, it'll give us cosine x equals negative 1. Okay, so here we have kind of like the first questions where they asked us what is cosine half from in these interval from 0 to 2 pi, but now we have two values instead of one. So our first value is cosine, here cosine x is equal to 1 over 2, and the second equation we have is cosine x is equal to negative 1. To get the value of x, we will have to take the inverse. So cosine inverse of 1 over 2 should equal to x, and here again cosine inverse of negative 1 should equal to x. We said here that the interval from 0 to 2 pi for cosine, the inverse of cosine for 1 over 2 is 60 degrees and 300. And if you use the unit circle for the second one, so let's try to find negative 1 for cosine. So not here, 180, that's one. So this is cosine, this is sine, to make sure that I remember it. So 180 is the first angle, and if we go around, yeah, it is only 180, which means that our final answer should be 60 degrees, 180 degrees, and finally 300 degrees. And that concludes our revision for the math.